What is the differences between Arduino and PLC? How are they different from a functional point of view? What are the benefits of each? And in the end, under what circumstance is Arduino a better option than PLC? If questions are important to you, stay with me until the end of this video. I'm really freaking pumped that you are here. If you are new here, what's up? I'm Ehsan. Make sure you hit subscribe so you don't miss any other video with me to help you along your engineering journey. Let's go to today's exciting topic about the differences between PLC and Arduino and see which is better option for our projects. Nowadays, the most popular programmable devices are programmable logic controllers or PLC for industrial automation and Arduino based devices for home and some industrial applications. The main scope of PLCs is industrial automation. After all, the first model, the Modicon 084, was created to replace the relay-based control system used by General Motors in the late 1950s. As soon as it was first invented and used, multiple enhancements leading to today's high-end functionalities allow the PLC to use in almost all industrial processes imaginable. On the other hand, The concept of Arduino started in 2005 as a part of a thesis submitted by a group of students in Italy. It has an open architecture and does not require expensive software application to configure. In fact, most are freeware which are developed by individuals and or electronics companies. It soon became prominent with hobbyists, including hackers, until finally finding its way to some industrial applications. Arduino is one of the most popular examples of a microcontroller. Arduino systems and PLCs have very similar operational concept. First, the controller accepts electrical signals via the input channel, whether discrete or analog, and saves the received signal as a computer register with a appropriate length that properly represented the input signal. Second, the controller processes the logic or user program that is downloaded to the controller's memory. Logic processing references the state of the input signal and executes the logic based on detected input conditions. Third, the controller updates the output devices wired to output channels, whether discrete or analog. This output update is the result of logic execution. Fourth, the controller performs internal system maintenance and resolves minor issues, of course, if existing, before automatically returning to the first step of execution. The repetition of this sequence completes a single scan cycle. Let's see what the benefit of using Arduino-based systems are. Lower cost. Arduino-based systems cost way lower compared to PLCs. This is true with add-on components. This is one of the main reasons why Arduino systems are popular with students and hobbyists. Flexible enclosure design. The base for an Arduino system is a bare integrated circuit board. It can be mounted directly to almost any area of device or processing being controlled. The housing or casing may be custom designed, or the device being controller may serve as Arduino controller's housing itself. A small and compact size. Arduino systems may be installed in almost any available space as it has very minimum space requirements. Additionally, the no-case design exhibits better heat dissipation. Open architecture. Arduino programming software is considered freeware. It employs Integrated Development Environment or IDE architectures wherein programming tools and facilities are packaged in one interface. Specifically, the code builder, test and debugging tool. Extremely mobile and portable. With a very compact form factor and customizable enclosure, Arduino-based system may achieve maximum mobility in portability. One great example of this feature is miniature robots that move from one location to another. These robots maneuver in tight space and are designed with sleek and slim bodies. Most of these robots are Arduino based. Availability. One can build Arduino based control system by purchasing Arduino components at your local electronics or hobby shops. In addition, with today's advent of online stores that sell products anything under the sun, one can surely find an available Arduino supplier. Common accessories and connectivity tools. Accessories are commonly used household items. Wires, communication cables, power supply, and some of these components. Surely, one may purchase ready-to-use and manufactured accessories. However, in times where creativity and customization are needed, these household components will surely come in handy. Support and community. Arduino's support and community are more of forum where professional and hobbyists interact and exchange information. It has a feel a non-formal community due to the mix of professions within. Now let's see what the benefit of using PLC are. Reliability. PLCs are manufactured based on standards set by NEMA, IEC, and certified by national and international standards such as UL, ISO, OPC, and others bodies. This ensures that certain PLC is manufactured following internationally recognized standard for operational reliability. Wide range of sizes. PLCs are available in many forms: compact, modular, and hybrid designs. Compact controllers are packaged controller with embedded communication interface, processors, I/O ports, power supply installed in a single housing. These compact controllers are slightly scalable, supporting the installation of some add-on components to enhance functionality. Compact controller typically can handle up 512 I/Os. Modular controllers come in highly scalable form. Basically, each part is sold separately. Power supply, communication port, I/Os, everything that you can imagine. Hybrid controllers are modular controllers with characteristic of compact controller. The base unit support the functionalities of compact controller, while the scalability feature adapts the capability of a modular controller. Open architecture. The architecture openness of a PLC is very different than that an Arduino controller. Open architecture with this control system refers to the capability of using different brands capable of interacting with each other. However, there are still certain and significant limitations to this, as it does not guarantee interoperability among different brands at a modular level. Scalability. PLCs are highly scalable. Scalability enables a controller of handling up larger I/Os, density, and integrated with more advanced functionalities and features. Operational lifespan. PLC are designed to operate at significant lifespan. Most of PLC's control systems operate at minimum of 5 years. However, most installations are replaced due to the obsolescence or hardware and components. Support or community. PLC community and support is available in online forum established by manufacturer or third-party community for a more open discussion. Additionally, each manufacturer, regional and country channel provide local, commercial and technical product support. The type of support for PLCs are more of a legal community. When to use an Arduino microcontroller, referring to the advantages that an Arduino microcontrollers offer. This device is best used in non-industrial, small-scale application or as a component of a large control system. The following list may be used as a guide to better help decide when it is appropriate to use an Arduino controller. Note that it's not necessary to meet all in the list, only the applicable items matter. Number 1. If your system is considered a micro small application, Arduino microcontroller is ideal for use in a micro or small scale application not exceeding 256 IOs. In fact, an Arduino controller may easily accommodate this IO density in terms of memory capacity. However, hardware assembly may somehow pose some installation challenge. Number 2. If the system requires a simple controller architecture, use Arduino microcontroller for implementation of simplex architecture. Simplex architecture is a single CPU operation. It does not offer fault tolerance. Thus, the failure of component or the CPU itself will fail the system entirely. Number 3. If the system does not require integrated safety, Arduino microcontrollers do not offer integrated safety feature. Some applications require a controller with a specific safety integrity level or SIL rating in an industrial automation setup. Some PLCs come with an inherent SIL rating, while others specifically function as safety controllers. Number 4. If the system required mobility, Arduino microcontrollers are more suitable for mobility applications such as robot or as a mobile component of a larger machine assembly. Number 5. The system has remote operation functionalities. Similarly, an application that includes mobility requires that the controller be an independent type or one that may control by a master controller remotely, whether the hardware connection or wireless access. Both PLC support this. One may find Arduino a better alternative as Arduino based devices is more mobile and may cost lower, which is the next consideration. Number 6. The system requires maximum cost effectiveness. As previously mentioned, Arduino microcontrollers cost significantly lower than industrial grade PLCs. For applications with low financial funding or application areas that are considered with a range of micro small controllers, an Arduino controllers may be considered and used. Additionally, with the programming software being freeware, the additional cost of purchasing programming software is eliminated. Number 7. Component availability matters. When engineering a control system, one must consider the availability of the core component and accessories and components too. When selecting a PLC, local support and hardware availability are major deciding factors. With Arduino being commercially available virtually at almost any electronic shop, availability is guaranteed. On the other hand, industrial PLCs, when out of stock locally, yes, most of the time it's happened unfortunately, must be sourced from a regional partner, which may give a lead time of 4-6 weeks or 8-12 weeks. Number 8. Compliance with industrial standard is not critical. Non-industrial application. Industrial standards require adherence and approval of certifying bodies. Almost all PLCs adhere to the set standards. This is why these control systems are the primary choice for industrial applications. Most Arduino products do not comply with these standards. However, there are a few new Arduino hardware that does. These products are recently released PLC like Arduino microcontroller. Still, most Arduino microcontrollers are in the original form that best fit non-industrial commercial or home automation application. Number 9. If the system required integration and connectivity. When it comes to integration, minimum requirements dictate that a controller must be capable of being connected to a visualization system such as supervisory control and data acquisition, or SCADA, or human machine interface, that is HMI. Whether industrial or non-industrial application, this is done via data exchange over one or several industrial protocols. For industrial setup, predominant protocols are Ethernet IP, Profibus, Modbus, CAN bus, RS-232, and many more. On the other hand, Arduino microcontroller natively supports a separate set of protocols such as LoRaWAN, UART, RS-232, Ethernet IP. There are published documents suggesting that the Arduino microcontroller supports the mentioned industrial protocols. However, the extent of connectivity is not yet well defined. When using an Arduino controller with integration and connectivity requirements, it must be fully compatible with any of these protocols. An additional consideration involves connectivity to databases, CRM, and ERP systems. For a non-industrial setup, this may not be a consideration. Still, when an Arduino controller is being considered for use in an industrial structure, this consideration must be included before deciding if Arduino fits the requirement. Number 10. Ease of use and maintenance. Arduino microcontrollers are programmed using the C++ programming language. In terms of practically, even experienced PLC programmers are not comfortable with this programming language. Additionally, most maintenance personnel within an industrial plant are mechanical and electrical personnel knowledgeable in relay ladder diagram, also known as technician language. When an Arduino control system fails, troubleshooting and program modification cannot be easily carried out. And finally, number 11, Internet of Things. Internet of Things, or Industrial 4, is a current phase of the Industrial Revolution. There are two terminologies for this, IoT and in the Industrial Internet of Things, IIoT. The concept remains the same, where data of remotely controlled and monitored device is sent to the cloud, internet, and accessed by the mobile device or workstation for operation and monitoring. When selecting Arduino microcontroller, classify if the application is an IoT rather than an IIoT. In some cases, an Arduino microcontroller may also be used to serve an IIoT requirement. Definitely, by hearing these detailed explanations, you will fully understand the differences between PLC and Arduino. If you learned some cool new stuff from today's video, make sure to subscribe to my channel right now. Goodbye for now, but stay tuned and see you soon.